Hi everyone. Today we're going to be looking at what is meant by the composition of functions. So in your notebook, please put down today's subtitle, Composition of Functions. If you check the dictionary, the word composition means to combine things together. And that's exactly what is happening here, except the things that we're combining are functions. So let's get that definition down. A composition is a combination of two or more functions in which the result of one function is used in another function. Here's a very simple example to illustrate this definition. So put example, please. Now suppose I give you two functions. So one function will be f, and f of x will be defined by the rule 2x plus 1. And I'm going to give you a second function, g. And g of x is defined by the rule x squared minus 1. Now, here's how composition of functions work. Suppose I plug a value of 2 into the function f. So I'm going to calculate f when x is 2. So that'll give me 2 multiplied by 2 plus 1, which gives me 5. Now here's where the composition happens. The result of f of 2, which is 5, I'm going to take that 5 and I'm going to plug it into g of x. So I'm going to calculate g when x is 5. So that'll give me 5 squared minus 1, which gives me 24. And this example illustrates how composition works. The result of f of 2, which was 5, was used in g of x. Now, how do we show this in one shot instead of doing it in two separate lines? Well, here comes a brand new notation. We say that since g of x uses the result of f of x, the way we write it is g circle f of 2, and all that equals 24. The circle symbol is literally just that. It's a small white circle between the g and the f. Now the order of the g and the f is important. The tricky thing about the order is remembering that the function that's written first, in this case the g, is actually performed last. So the function that's written after the circle is actually performed first. So let's get this down in an important color if you don't mind. What you see, in fact, proceeds from right to left. So in our example, f is done before g. Or in other words, g uses the result of f. So the order is extremely important, and you have to pay attention to that. Here's another example to illustrate how the order changes things. If I have g circle f in that order, that essentially means g of f of x. Or in plain English, g uses the result of f. However, if we switch up the order, suppose we write f first this time. So if we have f circle g of x, that's the same as saying f of g of x, and in plain English, that means that f uses the result of g. Now I'd like for you guys to try one on your own. So put another example, please. I'm going to give you two functions. How about, given that f of x is defined by the rule 3x plus 1, and g of x is defined by the rule 2x minus 1. Now, using these two functions, question A, I would like you to calculate the following. What is the value of f of g of, how about 2? Go ahead, pause the video and try it now. Alright, let's see how you guys did. Now remember, the order is very important. So if f is written first, it's in fact performed last. So first we're going to calculate g of 2. Now once you gain more experience, you can actually do this all in one line. I'm going to write it like this. I'm going to be calculating f of g of 2. Now, to calculate the numerical value of g when you plug in the 2, you can feel free to do it all within that bracket. So I'm going to be calculating the value of f of, and let's calculate g within this bracket. 2 multiplied by 2 minus 1. And that's going to lead us to calculate the value of f when, and the result of g is actually going to be 3. And that'll lead us to our final answer of 3 multiplied by 3 plus 1, which is 10. So when you gain more experience, you can feel free to do it all in one line. However, there's absolutely nothing wrong if you wanted to do it in two separate lines. First, you show the work of g of 2, which will give you 3. And then on the second line, you calculate the work for f of 3. Alright, question B. Let's switch up the order a little bit. I'd like you to calculate the numerical value of g of f of 2. Go ahead, pause the video and try it now, and feel free to either do it all in one line, like in question A, or if you're more comfortable, do it in two separate lines. Alright, let's see how you guys did. So, I'm going to be calculating the value of g of f of 2. And I'm going to do it all in one line within that bracket. So, g of, and the function f is 3 multiplied by 2 plus 1. So in the end, I'm going to end up calculating the value of g of 7. Which leads me to 2 multiplied by 7 minus 1, which is equal to 13. So, be careful. The order matters. Now, here's a very important observation. I want to throw out a question to you guys. The order does matter. And does switching up the order necessarily produce the same result? If you take a look at our two answers, obviously not. I would like you, please, to get that observation down in a very important color. Notice that f of g does not necessarily equal g of f. And there we have it, ladies and gentlemen. This is what is meant by the composition of functions.